Tonight, our speaker is Wil Orndorff, Karst Protection Coordinator for the Virginia Natural Heritage Program in the Virginia Department of Conservation and Recreation. He holds a master's degree in geology from Virginia Tech with emphasis in structural geology and tectonics. He's pursued an interdisciplinary career path that includes hydrology, biology, geomorphology, and analysis of spatial data. Orndorff's primary work focuses on dye tracing and other methods to characterize karst waters, especially for habitat protection of rare fauna. He does biological inventory of Virginia's caves to develop a larger and more representative database that can guide conservation decisions. He also collaborates with mammalogists to investigate the use of caves and the broader landscape by cave associated, yeah, not cat, cave associated bat species. He spends significant time working with regulators, developers, consultants, and agencies like the Virginia Cave Board to devise and implement strategies to reduce human impacts on karst resources. And without further ado, Wil.
Hey, thank you. Let me get this PowerPoint going here and see if I can make it work. Let's see.
And just a reminder to everybody, please put yourself on mute.
Okay, y'all see that? Okay, full screen, so it's working, right? Excellent. No?
Well, actually, it's showing us your side view.
Oh, that's not good.
So
Oh, hold
click
on.
Start Slideshow.
Let me try share again and let's see. Stop share. You'd think after all this time we'd be better at this kind of stuff, but no. Let's try this. How's that?
Oh, no. Yes, that's
Yes.
it.
Okay.
Hooray.
Okay. And also, before we started, I also said that I'd been underground with at least one of you, actually two of you, because Karen Powers is on the call as well, and she's one of the mammalogists that was alluded to in the introduction. And Karen and I have been working together for, gosh, pushing 15 years now on these problems and projects. It's pretty neat. Anyway, I'm going to talk to you guys about cave and karst systems, which comprise a really big part of Virginia's natural heritage. The picture on the cover slide here that you see is actually of a cave in Montgomery County that was only discovered about 10 years ago. And one of the recurring themes that we have in cave and karst work is that discovery is ongoing. And I think you guys know that from general biology, being master naturalists. But it really is over the top in terms of just the pace of discovery in caves and karst. Not just the animals that live there, but literally the caves themselves. All right, let's see if I can make this work. Okay, so a little primer for y'all. I think most of you already know what karst is, but I find it useful to go over that. Karst is basically a landscape that has been influenced significantly by the dissolution of bedrock. Most kind of rocks that you find under the ground around the world, granite, sandstone, quartzite, schist, basalt, etc., isn't soluble, or at least it isn't significantly soluble. However, rocks like limestone and dolomite in particular are are soluble, and they comprise a large percentage of the Earth's surface where they're exposed. So where this rock's exposed, you get dissolution, and as a result, a lot of the water moves underground. So in a karst landscape, you find these underground drainage networks, relatively dry surface environments, and all kinds of interesting landforms that you tend not to see elsewhere, like sinkholes, places where streams disappear in the ground, caves, of course, which we're going to talk a lot about today, and then big springs where all that water comes back to the surface. As I alluded to earlier, karst is most commonly developed in limestone, dolomite, marble bedrock, carbonate bedrocks, and not to get into a whole tangent, but all those rocks are produced by biogenic processes in warm tropical seas. So whenever you see a piece of limestone cropping out, you have to imagine in your mind that sometime in the geologic past, that limestone was being deposited in a shallow, warm sea somewhere. The ones around Blacksburg probably about 450 million years ago. Karst can be produced on other types of bedrock as well. We see it in gypsum, which is even more soluble than limestone. Um, Sometimes we see it in quartz-aragonite and quartzites, and that only takes place when you have a special set of conditions where biological processes help to increase the solubility. What can dissolve the rock can be atmospheric water when it dissolves carbon dioxide, or it can be water rising from or water mixing with gases rising from underlying hydrocarbon deposits to make sulfuric acid. But the common thing here is dissolution of bedrock. The classic karst dissolution, and what we see really at work around here is a result of carbon dioxide reacting with water to form carbonic acid. And carbonic acid, as you guys know, is not a strong acid, it's a weak acid. It's not, it's not, unless it's very concentrated, it's not going to like burn your skin or do any significant dissolution, anything it touches. But over time, it can dissolve carbonate bedrock. And what you can see here is sort of the simplified version of the equations, chemical equations that take place. Once you get this hot, carbonic acid H2CO3 formed, it separates into H plus, which is which makes it acid, and also interestingly HCO3, which is bicarbonate. Uh, the curious thing is HCO3, the presence of this anion is what defines something as being alkaline waters. So in these karst areas, you've probably seen at stores, there's people are selling alkaline waters for your health, this and that. Well, if you got a well in a karst area, you're getting alkaline water for free. So don't go buy that stuff at the grocery store. It's just a waste of money. Um, Once you get this acid formed, the H plus, which is what defines it as an acid, the hydronium ion, reacts with calcium carbonate, which is the mineral that comprises most of limestone, and it dissolves it. And it takes calcium and brings it into solution, and it produces even more bicarbonate. So what tends to happen over time in these karst systems is you build up a groundwater system that's really, really alkaline and has a lot of calcium and magnesium in it if you have dolomite. And as a result, you get what people call hard water, the kind of stuff that leaves deposits in your tea kettles, that kind of things. But what really characterizes these karst waters is the presence of bicarbonate, calcium, plus or minus magnesium. Now, when I talk to people about water, people always like to have that chemistry view of water that we just saw in the previous slide. When we think about water from our experiences as human beings, we have to remember that water is actually more like a soup than anything else. It's never pure H2O. In karst, it's going to have the calcium carbonate, the bicarbonate in it, magnesium, other things. But when you get out there and you pull the water out of your well or you see it coming out of a spring, it's got all kinds of other things in it. It's got other chemicals like sodium. It's got nitrate. A lot of that comes from people's putting fertilizer on the ground. It's got chloride, sometimes from road salts. It may have sulfate coming from anthropogenic uses or from natural sources. It also has other things that we introduce into the environment. There's that chemical that you see there with the benzene ring in the middle. That's actually a atrazine, which is a herbicide. And some places in the U.S. you can't draw a groundwater sample without picking up atrazine. The coffee beans represent coffee. If you're in an area where people are, you pick up caffeine in the groundwater system. Um, the little Mr. Yuck green guys, they're pathogens. There's all kinds of pathogens that are in the water. And there's also, unfortunately, human waste and sediment that both end up in there. So there's a whole slew of things that can end up in these water systems. So it's just a soup of things. And what's in that soup is going to depend on how we take care of the land surface above and draining to these karst areas. One other thing I didn't mention on here yet is that you also have these animals that are here. This is an example of one of the animals that lives in karst aquifers, one of a few dozen different species that live in Virginia. So you've also got animals that live in that aquifer and that depend on it for their life cycle. This is sort of an overview of an idealized karst landscape. What you can see here, and there's like hundreds of these you can pull up on the internet. No two of them are alike. But what they have in common is they show a land surface where the water is draining underground and then where it pops out along major streams that have cut all the way down through the limestone. if you think about it, karst systems kind of provide a way for water to short circuit surface drainage systems. So they go through these subterranean systems and they come out at springs to form base level rivers. In our area, it would be the North Fork of the Roanoke River. On the east side of town, the west side of town, it would be the New River. Some places along Sinking Creek, before it sinks, it comprises a base level stream. But carbonate karst landscapes are like this. It's got these features that are associated with that shortcutting of water uh, underground from where it lands on the surface to streams. And it comes out at big springs into these streams typically. Here's some pictures of some of these different karst features, what they actually look like. This is a sinking stream. This one's down in Smith County. I like this one just because it's spectacular and you can see pretty significant water flow just all disappears into the ground here, comes out of the spring about a mile away. Um, the termination is typically called a swallet or a swallow hole where the water disappears. Sometimes these things are covered up by other deposits. And when they're covered up by deposits, they form what's called a losing stream, where the water flows, and as it flows over reaches where the sediment is, the flow can drastically reduce or even disappear in dry times into a buried feature like the one that we saw in the previous slide. This is a location west of Harrisonburg called Dry River. And it's called Dry River because for about 9 months of the year, it's dry and it only has enough flow to bypass this losing portion during the late winter, early spring. If we get in an airplane or we take a drone up and look down on the Earth's surface, what we can see is a landscape that looks kind of confusing to us. You might think, well, this looks like a moonscape. Look at all those craters down there. And when I'm giving this talk to kids, be like, oh yeah, look, they're meteor strikes. And in some cases, that may be the incidence, but not here. What you're looking at here are sinkholes, and this is a photo actually from over in the Greenbrier Valley. But there's places down near Radford. There's places out near Mount Tabor, right near Blacksburg, all over Western Virginia, where you can look down and see these areas, what we term sinkhole plains. And what they are is flat areas that are pockmarked with places where surface material has fallen into the underground drainage system. And this is one of the real characteristic features of karst landscapes. Unfortunately, most sinkhole plains in the world, not just North America, also turn out to be pretty good agricultural areas. So there's very few places where we can see a sinkhole plain with native vegetation. And of course, the surface land use affects the quality of the subterranean animal communities that live here beneath the surface. So it's one of the kind of holy grail things in karst science is the few places in the world where we do have intact sinkhole plains that haven't been converted to agricultural or other human use. Uh, Another thing common in karst areas, especially where you have really pure limestones, like some limestones are almost all one mineral, calcite, calcium carbonate. And when you get that, there's very little soil or residual material left behind when it dissolves. And you get these areas where the outcrop is all, where the land surface is almost just looks like a pile of rocks. But if you go over there, you realize this is just the bedrock exposed. In some places, there's even less soil than this, and they call those bedrock pavements. The vegetation that you see there, lighter green, is all prickly pear cactus, and this is from a place down in Scott County. It's interesting to note that even here, karst helps create biodiversity because it makes a place where this prickly pear can live, and there's a type of squash bug that's known only from habitats like this in Tennessee and Virginia. And this is actually one of the places where we've collected it. So it's our karst biodiversity is not limited to the surface. Um, in karst areas, we also have a problem, of course, with, I've alluded to with what goes down from the surface into the karst systems. You can see here this farmhouse in Highland County, where somebody decided that they would put an outhouse on the edge of a sinkhole. Well, when we went over there to investigate, we found out there was actually a hole, a pit that even bypassed the sinkhole. So this particular resident was at some point using the karst system as a direct place to inject their waste. There's towns and cities in the U.S. and around the world where this has been the practice until recently. People seem to not want to make the connection that if you put this kind of stuff in the ground, it's going to come up your well. But awareness is getting better. We also build as we develop and make these commercial and industrial facilities, we build stormwater basins to control surface runoff. In karst, you can imagine what happens, and you can see it here where that water in a karst area doesn't want to flow on the surface, and it finds its way into subterranean systems and causes failure of these stormwater management facilities. This particular sinkhole you're looking at there with my friend Joey Fagan is one at the Walmart in Wytheville. This was taken about 2004, and at this time there were 9 separate sinkholes in the stormwater basin. So every time it rained, the stormwater basin would just take water and put it right in the aquifer that was supposed to be treated in that facility. Sometimes people dump things in sinkholes. This is another bad use that introduces contaminants into the groundwater system that we try to avoid. So now let's go look at some of the cool stuff underground that is in surprisingly good condition given all the insults that we do to karst on the surface. Um, First thing you need to do to go underground is you have to have a good team. And this team right here that went with me this day is my wife Zena on the left, and in the middle is my daughter Naomi. And I like to show this picture because it kind of gets into some of the adventurous and also fun aspects of caving and karst exploration. Here we go. She is tying the rope that we're going to go down about 100 feet into the ground on, and she's been doing this since she was before she remembers. Let's just put it that way. So it's kind of a fun thing. So of course we make her go down first to make sure the rope's safe, and then her parents follow. Once you get down in the caves, you can see some really neat things. Sometimes you see where the water comes in. This is a waterfall in New River Cave in Giles County, which I'm sure some of you are familiar with New River Cave. I know at least 2 of you are. And this is when you get back to the waterfall, you can look up and see the other end as water rushes into the cave. Within the caves, you see water doing all kinds of things. It drips in, it comes in side tributaries into large pools. This is a cave in Scott County. Sometimes that water that comes through caves is saturated with minerals that it's dissolved on the way into the cave. And it redeposits these minerals to make lots of interesting things. These are travertine rimstone dams that you see here coming out of this little stream passage in a cave in Scott County. This is another picture of that cave from here in Montgomery County. Water's coming in, and as the water comes into the cave, it makes those formations that you see to the right of the landowner there, who we took into the cave. You got stalactites and stalagmites and draperies, and I won't bore you with a lecture about all the names of speleothems. But depending on how the water drips into the cave and how fast it dissolves and what's in it, you get a whole slew of really beautiful things that appear in caves in terms of mineral deposits. The waters flow along sculpted cave floors like a surface stream does on the surface, except there's a roof on top. And eventually these waters are going to return to the surface. Before they do, however, sometimes they leave behind evidence of where they were in the geologic past. This is a cave in Giles County where you can see a paleo or ancient water level represented by that horizontal line on the on just above my colleague Tom's head there. That line's now about 150 feet above present day surface stream levels. So over time, these caves are exposed, but when they were formed, most of the cave speleogenesis, origin of the caves, took place under the water table. The water comes back out at the surface eventually, and it comes out at springs. Um, Most of Virginia's largest springs are springs that come out of karst aquifers, and many of the springs in the U.S. and the world that are the largest springs are coming out of cave and karst systems. All the major springs that you hear about in Florida, where they have all the parks and the mermaids and all that junk, they're all karst springs. Biggest karst springs in the U.S. are down in Missouri. There's some big ones in Texas. And the Appalachians ours tend to be a little bit smaller, although they're still springs that will produce several million gallons of water a day. But because our rocks are folded and faulted, we don't have quite as big areas contributing to individual springs. A lot of these springs were used in the past, and many are still used today as public water supplies. This is a spring where I just got done doing some work up in Frederick County, Virginia, called Fay Spring. And it literally is right off of just east of I-81. If I could knock the building out of the way, you might be able to see a tractor trailer behind it. I could not find that picture today of a truck driving behind, but I have one somewhere. And What's happened in a lot of these springs is that they've become contaminated because um, we got become contaminated because of people building their communities in the recharge areas of these springs. And this spring in Winchester, for example, has elevated salt levels, has elevated nitrate levels, all things that are strongly reflect the signature of human activity that make it much more difficult to treat this water for use as a water supply. So the locality there still owns this as a backup water supply, but they don't use it in general because of that history. Blacksburg, for example, had springs that were used to supply the town at one point. Some cities still do. Pulaski does. The city of Stanton does. Harrisonburg still does. Waynesboro still does. So there's still a lot of use of these karst springs as water supplies, which gives us a real incentive to learn about them and protect them. Um, One of the neat things about karst springs is they can actually contribute positively to surface water quality. Now, just because water's clear doesn't mean it's clean, but it's a good visual illustration here. This is the confluence of a cave spring, one of the caves you saw a picture of earlier, with the Powell River. And you can see following a precipitation event how muddy the surface stream is and how relatively blue and clean the stream coming in from the karst tributary is. And this is kind of a neat place where the surface river, when it comes up, actually makes a dam, and the water from the cave spring backs up behind it like this and just creates this really interesting visual representation of the water quality. So globally, where do we find karst anyway? Well, anywhere you see red on the map is karst. A lot of it in North America, a lot of it in Europe and Asia, a little bit less of it in the southern hemisphere, but still all around the world we have karst. The term itself comes from Slovenia, which is just to the east of Italy on the Adriatic, kind of north end of the Adriatic. And it's a term used for a place, the term's actually for a place called the Cross, but it got translated as karst. As people tend to butcher the languages of other people. But anyway, that's where karst or cross was first defined because Slovenia has a very, very distinctive karst. And much of the ways we talk about karst are derived from that terms that came in that area. You can see where we are in Blacksburg in a belt of karst that runs down the Appalachian Mountains in the eastern part of North America. If we zoom in just to the US, you can see areas where we have karst. This is produced by the USGS, so of course it has every conceivable variation of karst that you can imagine, including pseudokarst shown on the map. But for our purposes, we're mostly concerned with the blue parts, which is where we have carbonate bedrock, which produces the kind of karst that we're most familiar with and that we're talking about today. Zooming in even more, we can go into Virginia, and we can see here a map of the Virginias, actually, Virginia and West Virginia, and the counties are labeled. You can see where carbonate bedrock, and hence karst, is developed. It's color coded by the age of the bedrock, and depending on where you are and what kind of rock you have, it can influence the kind of caves and karst systems that are formed. If you go from southeast to northwest, you go from older bedrock, Cambrian and lower division age carbonate bedrock through progressively younger bedrock until you get to the Mississippian age, to about 320 or 30 million year old carbonate bedrock out in the Greenbrier Valley of West Virginia. And that also makes it some of Virginia's biggest caves where it's exposed down in the Powell Valley in extreme southwestern Virginia. This isn't, I'm not going to lecture ad nauseum about these different rock units. The whole thing is to point out that there's variation, there's diversity in the limestones and in the rocks in which the karst is formed, and this helps influence the biodiversity in these systems. And what we show here is one of the things that most people are familiar with when it comes to caves and karst is our show caves. Caves, where they're lit up, they have tours, they charge you to go through, that kind of thing. I know that maybe only two of you have ever been in a cave with on a wild cave, and a few more of you have probably been in wild caves, but I bet most of you have been into a show cave. And I always want to give show caves a little bit of credit here because they do more to introduce the general public to caves than does anything else. And you can see here where the show caves are located. A lot of them are concentrated up in the Shenandoah Valley, and that's not because that's where the best caves are. That's because that's where the people are who can pay to go in the caves. The caves are spectacular, but they're not uniquely spectacular up that way. So here's the show caves. You can see again concentrated north. The only one we have around here that's still open is Dixie Caves, or Dixie Caverns. They're in Salem. To really get to where the concentration of these caves is, you have to go a couple of hours up I-81. We do have one show cave that's part of the National Park System, which is Cujo's Cave at Gap, Cumberland Gap National Historic Park, which is at the extreme southwest tip of Virginia, and is where I'm heading tomorrow morning to count bats, by the way. In Giles County, we used to have a commercial cave, show cave called Giant Caverns, and that's recently been purchased by the West Virginia Cave Conservancy. And there may be opportunities in the future for more people to get to visit there, depending on how management proceeds. It's complicated by the fact the old tour entrance collapsed a couple of decades ago. So in show caves, Virginia, we have a bunch of show caves you're mostly familiar with, and we have a bunch that used to be show caves. We're sort of past the golden age of show caves in Virginia. You can see we have 6 caves there on the right that were opened as show caves in the past and are not now. One of those, the Caverns at Natural Bridge, is actually a cave that we will DCR, my agency, recently purchased, and we'll have some limited access in the future once some of the apparatus from the old show cave has been removed for safety purposes. If you throw the wild caves on here, you can see all those yellow triangles. They represent all the known caves in Virginia, or all the known cave entrances. And you can see that these show caves just exist in a sea of wild caves. So if we compare the show caves, which most people know about, to the wild caves, we have a total of 3,658 caves. Longest cave we have is a wild cave, about 30 miles long. Longest show cave is the one at Cumberland Gap that Park Service has. But the next longest is Endless Caverns up in Shenandoah Valley. The caves that aren't show caves get up to a quarter-mile deep, much deeper than the deepest show cave. The other thing is, where we consider all caves, they're concentrated differently from where the show caves are. They tend to be farther west and farther south. Giles County, right here adjacent to Montgomery County, has one of the largest concentrations of caves in the U.S. and in Virginia. Go on. So if we do a map scaling the caves by size, you can see that the show caves just kind of disappear into the noise. There's still some pretty significant caves, especially up in the valley. But as you get down in southwestern Virginia, with the exception of Gap Cave there at Cumberland Gap, the show caves really don't comprise much of the significance in terms of the total number of caves. But they are important because they teach visitors and community members to value caves. We get almost 750,000 people per year visit show caves in Virginia, and they really provide an opportunity for messaging and for people developing an appreciation for caves. We also, of course, have government agencies that deal with caves in Virginia. We have the Virginia Cave Board, which was produced by the Cave Protection Act. We have the karst program, which I work for at DCR, which was established by an initiative of the Cave Board. Department of Wildlife Resources has concerns with caves, mainly for vertebrate species like bats and wood rats, and some invertebrate species that have protections under state and federal Endangered Species Acts. Department of Transportation, by necessity, has to deal with caves because road cuts are great places to discover caves, and there are a lot of roads run along valleys in close proximity to cave entrances. So VDOT does a lot of work with caves as well, and is a good conservation partner. The Protection Act I alluded to was in 1966 initially, but was revamped in 1979 to provide a lot of protection to Virginia's caves. The big Achilles heel of the Cave Protection Act is that it pretty much lets a landowner do whatever they want with their cave, except for selling speleothems or cave formations taken from the cave. But other than that, landowners' rights are still reign supreme over the protection of the resource. The Cave Protection Act established a governing board called the Cave Board that basically is more of an advisory board than a governing board uh, that helps interested parties throughout the state take care of cave issues, provides expertise. One of the things it does is it maintains a list of significant caves that we screen development projects against. So if something looks like it may impact a significant cave, everybody, prairie dogs, and it's like, okay, we need to do something and try to avoid impacts to these caves. And that has been an extremely effective way of protecting cave and karst resources through this significant cave list. Um, so there's 12 categories of significance you can see on the cave list. Length, depth, aesthetics, the hydrology, biology, geology, paleontology. There's fossils in caves, archaeology, evidence of past human life in caves or human civilization. History, historical things get preserved. Economic uses like the show caves. Recreational uses for the 500 or so people in Virginia who are cave explorers, or at least recreationally. And then there's atmospheric significance as how air moves through caves. Um, we maintain a list of the Cave Board in combination with the Virginia Speleological Survey maintains a list of caves that comprises about 10% of Virginia's caves. And these are the significant caves. That doesn't mean ones that aren't on the list aren't significant. We also try to protect those, but these are the ones that are highest priority and are sort of pre-identified as having resources that we think are important. Here's an example of a recently discovered significant cave resource from a cave up in the Shenandoah Valley. This is a 3D scan of a peccary skull that was discovered in a wild cave on the property owned by Shenandoah Caverns, which is a commercial cave up in Shenandoah County. You can see here how intact and beautiful this skull was over on the top left when it was removed. Peccaries are still extant, some peccary species down in South America and Central America, but they've been extinct from this area for since early in the Pleistocene or in the Ice Age. And so finding intact peccary remains like this are really exciting. At this particular location, there looks like there's multiple animals, and this is one of the many criteria by which a cave may be designated significant in Virginia, is this paleontology criteria. Another criteria is biological, and we're going to do a deep dive into that in a little bit. This is an example from Dixie Caverns, which is a commercial cave. Yet it has a species of salamander that's known only from Dixie Caverns and a couple of other caves in the immediate vicinity. Really tiny range. It's called Plethodon dixii, and it's a sister species to the Blacksburg salamander, Plethodon jacksoni. So it's kind of interesting. This group used to all be synonymized or considered to be the same species, these slimy salamanders in the genus Plethodon. And recent work that Karen Powers and others have been involved with over the years has really divided Plethodon out, showing that there are a lot of really legitimate species that used to all be considered the same thing. And we'll come back to that sort of theory in cave biology a little bit later. Um, so the people I work for, we were started. My office has been around for 32 years now. I've been with it for just over 26. Um, we've had ebbs and flows in staff over the years, and we used to be funded by EPA money for about the first 14 years of our program. About 10 years ago or so, we actually went on state general funds, which means taxpayer dollars. Once it was determined through our efforts that the component of biodiversity that we have in caves and karst is significant enough to merit programmatic funding and not just grant funding that is unreliable. So it's pretty interesting. And it seems like we're pretty stable these days. We actually have a couple general funded positions, and we do pretty well in terms of getting other money to help support our contract and wage staff. So before I dig into cave inverts, which is the really, really cool thing about the cave biodiversity, got to talk about bats a little bit. Now, I strongly encourage you all to get one of your members to give you a much better presentation on bats than I'm going to give you tonight. But I would like to talk a little bit about the bats that use caves in Virginia. In Virginia, we have 8 bat species that commonly use caves. Little brown bats, big brown bats, tricolored bats, Indiana bats. gray bats, eastern small-footed bats, Virginia big-eared bats, which is our state bat and our most distinctive looking bat, and the northern long-eared bat. The ones that I have underlined and highlighted in yellow are all bat species that were affected by a disease that appeared in North America in about 2006 called white nose syndrome. And I expect most of you have heard of that. Um, but when white nose syndrome struck, uh, it spread like wildfire across North America. 2007 was the first documentation of it. Later, we realized from photos that it had shown up in 2006. By 2009, it was in Virginia. A year later, it was all the way down in Tennessee, Alabama, Georgia area. And now it's pretty much endemic across the U.S., with maybe a few areas where it hasn't been confirmed. The problems with white nose syndrome gets its name, by the way, from a characteristic fungus that tends to show up around the muzzle of affected bats. White nose really, really just decimated bat species. And but for example, little brown bat species, about 95% mortality in the eastern U.S. Tricolored bats, a little harder to estimate, but pretty high mortality. Indiana bats were hit pretty hard. The species there at the bottom, northern long-eared bat, was probably extirpated from many of the cave and karst areas, although residual populations that are coastal and not in limestone areas still seem to be persisting. And it may have been the species that was hit the hardest. But little browns were, if not, were a close second. What's another interesting thing to point out is that there were some species that weren't affected by it, and gray bats, which are a federally listed protected species, seem to have completely ignored the disease, even though they contract the fungus. So it's a part of the natural history of these animals that's interesting that we don't know much about, is why some species were so susceptible and why others weren't. And I could make up a bunch of things about it, and but I don't think I I really don't think we know and figured out what's governed susceptibility at this point in time. You can see here some little brown bats. One of the reasons they were susceptible to transmission, not necessarily susceptible to the pathogenic characteristics, is that they tend to hibernate in clusters. And so if you get one animal that has the disease, you are going to easily transmit that fungal spore to other animals. And up in New York, where this started, you had extremely high concentrations of little brown bats, which encouraged this disease transmission. There's a tricolored bat. These guys actually seem to be doing pretty well. Taxonomists love to change the names of things when they look at their DNA. And this used to be called a pipistrelle based on a European genus called Pipistrellus. And turns out it's more closely related to North American Myotis species, hence the name Perimyotis or near Myotis subflavus. In any case, it's a beautiful bat, and these guys are present in almost every cave in Virginia in small numbers, even after white nose syndrome. Indiana bats were for a long time the bat of greatest concern of conservation in Virginia because we were sort of on the edge of the range and populations were severely dwindling. As you can see, they also hibernate in a way that's very conducive to pathogen transfer. They were hit pretty hard by white nose, but we've been counting them this winter. We're still seeing numbers. We don't know what the future holds for this animal, but there are survivors. What we're more uncertain about is sort of the reproductive activities leading towards future recovery. Northern long-eared bat, this is an example of a bat we're looking at here for assessing wing damage from white nose syndrome. And this used to be the most common bat we'd find in the summer in the mountains of Virginia. I haven't seen one for 2 years. So these are really, really few on the landscape now in limestone areas where white nose was present. These are small-footed bat. This guy seems to be doing okay. Doesn't appear to be succumbing to white nose to any significant extent. They're the tiniest bat in North America, and they're also sort of a cold-loving bat. You find them in caves in very cold parts, and they hang out on the walls in solitary teams. In the summer, they hibernate in talus slips. They're a really cool little bat. Big brown bats, I think this is next to the last one I'm going to show you. They're the ones that are sort of the most luxurious looking. They look like something you could, a trapper would make little tiny fur coats out of. They're really beautiful bats. They're the biggest bat that uses Virginia caves. And fortunately, they don't appear to be very susceptible to white nose, although they do get the fungus. They are, if you ever go to New River Cave in the winter, you'll see 100 or so of these in the entrance area hibernating, but they're a really cool bat. And finally, we got this guy, our state bat. This is sort of the rarest bat, or at least was prior to white nose syndrome. Mostly it was rare because it had very limited habitat. It only liked to be in areas with caves at elevations of over 2,500 feet. And that limited it to high elevation caves in Tazewell, Bland, and Highland counties, and then over in Pendleton County, West Virginia. The world's largest population of the Virginia big-eared bat is actually in West Virginia, which is kind of comical. A cave called Hellhole, where there's 10,000 or so that's still roost over there or hibernate over there in the winter. And in the summer, these guys will use caves. Fortunately, they are not susceptible to white nose syndrome either. They probably are susceptible to global warming, however, because as uh, temperatures increase, that elevation line is probably going to increase as well. The Virginia big-eared bat is a subspecies of a more widespread bat called Townsend's big-eared bat that has other subspecies in the Ozark and then in the western U.S. Here's white nose syndrome. Talked about this already. You can see here the muzzle. That actually is the first individual photographed, I believe, from the cave up in Howell's Caverns in 2006 up in New York. But this spread very rapidly and killed millions of bats in North America, as we said. It's believed to have been brought here from or come here from Eurasia, where the pathogen is widespread and more diverse than it is here. If you look here, this is a map from 2025. I could have downloaded a new one. The story doesn't change that much. Basically, anywhere you see any of those colors, you know that they have detected white nose syndrome, and uh, it's pretty much present wherever there's cave dwelling bats across the U.S. at this point. Now, moving on to the thing that our program really concentrates on. So natural heritage, our whole currency in our agency is rare species, rare things that need to be protected. And it turns out caves create environments that are rare species generators because surface species adapt to caves, but the caves are all isolated, like miniature little Galapagos Island areas. And so in each little area where you have an isolated group of caves, you'll get a different set of species. Now, there's exceptions to these rules, but in general, there's a high degree of endemism or geographic restriction to cave adapted species. Some of the adaptations that we see are vestigial eyes, a lot of setae, like on this spider here on the right. There's enhanced chemoreceptors, selective hearing, kind of like some of your children and family members, I'm sure, have unique reproductive strategies, metabolic adaptation, lack of pigment. So all these things if it takes energy to do something, uh, but it doesn't provide you benefit, animals evolve over time to stop uh, having that characteristic because it's a waste of metabolic energy. Um, Biogeographical characteristics, as I mentioned earlier, is that they're highly endemic due to concentration in isolated cave or karst areas or systems. Troglodytic species distribution by rarity in Virginia. This is about a 10-year-old diagram, as you can see. I need to regenerate it. At this time, we had 162 cave limited species described in Virginia. Right now, we're approaching 200. So in 10 years, we've added nearly 40 additional cave species in Virginia's cave and karst. So as I alluded to earlier, it's a really active field where discoveries are taking place all the time. What this graph shows is the y-axis or the x-axis is showing you the rarity. G1 is the rarest of the rare, and then from 5 or fewer locations, G2, 5 to 20 locations roughly, G3 more, and then G4 and 5 is pretty common. You can see we have this sort of weird distribution where you're most likely to see a rare species in a cave because every time you go from one cave area to another cave area, you're getting into an area where some species are very endemic. So the majority of our species are extremely rare in caves. Here's an example of one of these animals. This is a genus Sacatodia, which is an isopod genus, crustacean. Um, this one, probably an unthanked cave, but these things are very common, but they're very speciose. Depending on where you go, you're going to hit different species. But you can see they're really beautiful animals. That one's about I think 19 millimeters long in that photo from the tip of the antenna to the tip of the telson on the tail there, or the uropods on the tail. Here's a photo showing some of these animals in spring, and some of this biodiversity is associated with springs as well. And it's kind of neat to see how they move. They just crawl around, they filter feed off the bottom of the spring. Let's see. This is a different type of isopod. We'll talk about this guy a little bit later, but this is a marine ancestry isopod that lives up in caves in the Shenandoah Valley called the Madison Cave isopod. You can get up to about 20 millimeters long. This is an amphipod, another crustacean. We have several dozen amphipod species that live in Virginia's caves and groundwater. And these are free swimming animals. We also have these wonderful flatworms, planaria. And the planaria are great in the fact that, when you see them all stretched out, you can say, oh, this thing has some structure. But if you start disturbing them, they will just condense into an amorphous blob. There's very few people in the world who study planaria, especially the taxonomy of them, because they don't have any hard body parts. And it's really hard to do traditional taxonomy on these. We may see a resurgence in interest using molecular or DNA methods. Here's a cave beetle. These are among the most speciose species. Between Virginia and West Virginia, we have about 70 different cave beetle species. About 50 of those are in Virginia. You might say, well, that's not white. That animal's got color. Well, the color here is not due to pigment. It's the color is a side product. It's actually what's called sclerotization, which is providing hardness to the exoskeleton. So a lot of cave animals have this amber color, which just happens to be the color of the hardening agent in the exoskeleton. This particular cave beetle you see here is a cave beetle called a horologian cave beetle. This was a holy grail of cave beetles in Virginia and West Virginia, known from a single specimen from a single cave just north of Lewisburg. A couple of years ago, we discovered a population of these type of beetles up in a cave in Bath County, and now we have a second species within this really, really cryptic eye group of beetles, and we're hoping to find some more. The key is to know where to look, and they seem to live between the Earth's surface and the caves, which is a habitat we don't really have direct access to. Show you how these guys move around. This is a cave beetle. You can hear water running in the background. So when we try to catch these things, we're trying to catch them with a paintbrush, like a little paintbrush that's wetted on the end, or sometimes a little aspiration device. And cave beetles can be really tricky to catch. They don't like to stick to the paintbrush, and they constantly move. And usually they're moving towards a hole or some kind of escape route that they have predefined. So cave beetles are very diverse, and they're also tricky. We have spiders. This is a cave spider that lives near cave entrances called a meta genus spider, really pretty, kind of ubiquitous in Virginia's caves. We have completely cave adapted spiders as well. I believe this is a spider of the genus Nesticus, and you can see all the setae or hairs all over this animal's body to detect its environment, move around. We have these primitive insects or pretty primitive hexapods called diplurans that are present in a lot of caves. And they're also known as bristletails. And they're a very interesting animal. This is a liticampid dipluran, and they're a predator. They also have a cousin that's a gepigid dipluran, like this guy. And they actually have this hardened or sclerotized tail with a really hardened circe on the end of the tail, and they actually use it to hunt. And so they'll catch things with those pinchers and then bring it forward to their mouth parts to eat. So another really kind of cool adaptation of these animals. Some of the coolest looking cave animals are pseudoscorpions. called pseudoscorpions. They look like scorpions, but they don't have stingers. And they have really, really long claws so they can grab prey and bring to their mouths. There's a lot of diversity in these, and there's a lot of species that have not been described within pseudoscorpions. They were also some of the earliest land-dwelling animals on planet Earth that can be traced all the way back to the Devonian. But yeah, really, really neat animals. This is one of the exceptions to the rule of endemism here. This is a pseudoscorpion called Hesperchernes, and there was a guy who studied pseudoscorpions, was doing his PhD, and he thought, well, I want to determine how many species there are within Hesperchernes, figuring he'd have dozens across the karst of the eastern U.S. And it turned out it's one species that's widespread. And what he's discovered is that this species most likely is so widespread because it hitches rides on bats from cave to cave. We also have millipedes. This isn't the Ellip millipede, but the Ellip millipede looks a lot like this. Lots and lots of legs. They have setae on their back to sense their environment. And they're detritivores that live in a wide variety of cave and karst environments. This one is the Ellip millipede here, as you can see. It's really, really beautiful animal. That's the one that lives in the Eastern Divide Natural Area Preserve, kind of between the east side of Blacksburg and the North Fork of the Roanoke River. Nowhere else on Earth. Um, I think that was actually a mite, not a spider. I spoke wrong earlier, but beautiful mite here, photo by Ned Rose. And you can just see the fascinating cilia or setae on the animal that allow it to detect its environment, move around. Oops. This is a springtail. These are an understudied group. They're really tiny, and they're probably what the beetles and the diplurans and some of the other predator species are eating. We have a couple dozen species of springtails documented in Virginia, but as you can imagine, they're a group that's difficult to work with because of their size, and there really aren't a lot of people who are actively working on springtail taxonomy. Another one there. Just really cool animals. Okay, so talk a little bit about the biodiversity distribution. You can see places all across the eastern U.S. Where these animals are distributed. The redder the color, the more biodiverse the area is. You can see the really concentrations of high species by rectangle size are kind of out in Kentucky or maybe down in Georgia. But if you look in Western Virginia, we have a moderate level of biodiversity all the way up and down Western Virginia. So at the state scale, we actually have more biodiversity than they have in Kentucky and about the same as they have in Tennessee. We're like the second most biodiverse state in terms of cave and karst animals in the U.S. Um, some animals that you think about being adapted in caves we don't have in Virginia. For example, cave adapted crayfish. They're pretty much known only from like the interior lowland plateau and not really from the Appalachians, although there is a cave fish, crayfish with eyes from the Greenbrier Valley that is of dubious cave affinity, in my opinion. Cave fish are also only known from out in that area. But what we have in Virginia in droves are these invertebrates which are really and specifically the small invertebrates, unlike crayfish, which are much larger animal. That seems to be our biodiversity concentrate. This particular one, the Cearlandidae spot, which is of uh, a marine origin, is known from only the Shenandoah Valley of Virginia, and there is nothing comparable to it elsewhere. So that's sort of our particularly unique thing we have in the Appalachians. Um, we've discovered a bunch of new species since 2016, 30 plus new species of isopods in springs and caves. This was driven a lot by starting to do molecular work, and I'm not going to go into all the details about this, but we published a book called The Groundwater Isopods of Virginia. We're currently working on the second supplement. There's 50 couple species in here that are described. We've got another dozen, so another six were described in the first supplement, another six coming out soon. So we may be starting to run out of isopod species in Virginia's caves and karst, or maybe not. Um, to do this work, you have to go out and poke around at springs and caves and spend a lot of time with your face in the mud or your face in the bottom of rocks in places that are difficult to get to, as you see here. And then once you get these animals, you have to go back and you have to look at them under microscopes, photo document them like Dr. Lewis, Jerry Lewis, who's the lead author on this, is in the center there. And then we send some specimens to our collaborators who do molecular genetics The person you see on the left is Dr. Florian Millard, and that's one of his colleagues on the right in, believe it or not, in Lyon, France, where the World Isopod Project is. I bet you didn't know there was such a thing, where the World Isopod Project is headquartered. So all this work led to the discovery of all these species of isopod. What you see here is actually a cladogram or a molecular phylogenetics diagram for another group of animals called the cave beetles. But a similar diagram exists for the isopods where you can see how the genetics uh, divide out and make these trees, these taxonomic trees, that actually hold up really well to descriptions based on the morphology of the animals. Um, so with the isopods, we had only 4 species in the geographic area shown in this map, and you can see now each of those symbols represents a different species with a particularly high biodiversity down in the Upper Tennessee River Basin of extreme Southwest Virginia. You also notice they're kind of interesting. There's an area from Blacksburg down to the Upper Tennessee where we don't have any aquatic isopods in the caves, and that remains a puzzle for us to try to figure out. Here's some of these different isopods photographs. You can see they're quite diverse, even at appearance that you would be able to see with the naked eye. This is the most cave adapted one we found so far from a cave down in Lee County called Lytton Cave that actually runs underneath a U.S. highway and has one entrance on a federal prison. So this animal's habitat is in no way secure. Beyond the isopods, we have 11 new beetle species, a bunch of millipede species to be described. There's some cave snail species, spiders. There's just a whole lot of things out there that are more than we can keep up with in terms of descriptions. We find the stuff, we farm it out to taxonomists, and then they hopefully describe it and get it into the scientific literature, which helps us with conservation. This is a new species of spider, for example, from a Virginia cave that was new to science as of 3 years ago. So the closing thoughts on the cave biology, we're still kind of riding high on the species accumulation curve, and I think by 10 years from now, somebody other than me will be giving this talk, and they'll be talking about all those things we discovered since 2026. And that's one of the really, really cool things about the cave and karst science. I'm running low now, I think, on time because I know you guys, time is our most precious resource, and I was supposed to talk, I think, for an hour, and I'm kind of rubbing into that time here. So I'm just going to go through real quick, if it's okay, just some pretty pictures from Virginia Caves. Then I'll take some questions from you. And if anybody needs me to stop, just speak up, or else I'm just going to try to blast through these photos because they're real pretty. Okay, I don't hear any complaints. I'm going to go. This photos are by a guy named Ryan Moore from Under a Rock Photography. Really good cave photographer, a fellow cave explorer who has a business on the side. So I'm going to give a shout out to him. Here's a picture of cave from Unthanks Cave in Lee County. These are all Ryan's photos. You can see how spectacular some of this cave passage is. Just absolutely gorgeous. Unthanks Cave is a lot like a lot of the caves in Giles County, developed in Ordovician age limestones, has deep water in places. It has historical graffiti in there as well. These caves have been visited for up to 200 years in some instances, and we see old graffiti, which today we would call it graffiti and vandalism. But if it's old enough, it becomes a historical resource. It's one of the paradoxes of human endeavors. Another picture there of Unthanks Cave. This is one of the dwellers in Unthanks Cave, which is that Secunodia isopod you saw earlier. We go to a cave called Ogden's Cave at the other end of the state. This is an absolutely beautiful cave, the longest cave in Frederick County. We have a gate there to protect it because there's a long history of trespass in this cave. In order to protect the biological and mineralogical resources, this cave, like others, had to have a gate installed so we could control access. To get into the cave, there's also sort of a natural gate, which is this pool that you have to sometimes go all the way underwater or other times go almost underwater to be able to access the majority of the cave. This cave entrance. This is a guy who helped protect a lot of caves in Virginia. His name is Larry Smith. He was my boss for years. And this is a photo of him in Ogden's Cave. And I always like to show this because no one should ever wear sunglasses in a cave. But thanks to Larry, we protected a lot of caves despite his dubious choice of eyewear. That particular cave we were able to protect because it had this globally rare cave beetle that I discovered in there that we previously thought was extinct. It was only known from a commercial cave prior to that. So, and again, our agency, rarity is currency. And when we find really rare things, that helps liberate resources to protect the landscape where they live. Stay High Cave is the closest natural area preserve cave, other than the ones on the Eastern Divide, to Blacksburg. This is in Clover Hollow area of Giles County. You can see one of the waterfalls here in this cave. Vertical pit here, uh, person on rope here, looking up a pit here. This is the most technically challenging cave that we have as part of the state cave portfolio. A lot of rope work and a lot of water, which make for a dangerous combination. We actually had a rescue there in 2011, which led us to have to install a gate on this cave as well, due to prevent people from going in and hurting themselves and hurting the resource. The Cedars down in extreme southwest Virginia has some of the best caves in the Natural Area Preserve system. We'll see a few pictures there, kind of illustrative of the caves in Karst, Virginia. This is a picture of a karst window where water sinks underground. Um, this cave preserve was bought because of this species, Lee County cave isopod, which was a federally endangered species known just from a handful of caves, which are now all within the preserve system. This is one of the type sections for the type localities for the Lee County cave isopod. And this cave was so contaminated at one point that the isopod had disappeared. But through our efforts over the last 15, 20 years, the isopod population has been restored here. You can see another picture of the same room. Another cave pool, deep cave pool in the Cedars. Um, some typical landscape in this area in the karst. And another one of the caves here, Surgeon Gallahan system. And water moving underground is the theme. You can see places here, big, broad passages where water no longer moves except during extreme floods, but which represents a period in the past where the cave was being formed. You can see here water pouring into the cave from above, from the epikarst, making this haystack formation in the stream that you see here. And then that water, if you walk out from there, you come out at this beautiful spring entrance, which flows into the Powell River. So this cave and karst resources really are part of a broader landscape, and I like to keep reminding people of that. Finally, I'll take you up to Madison Saltpeter Cave. This is where that rare animal, the marine relic, the Madison Cave isopod, was first known from. And what you see in front of you there is a deep fissure filled with water in the cave, and the scum on the surface is actually calcite. It's actually mineral rafts that get deposited on the surface of that pool. And it creates for just quite a beautiful visual. This is a place of much reflection for people, sitting there looking at this area and studying the life that's kind of unique to this particular cave system. And that's the species known from there. It's the only species in the Appalachians that has a direct marine ancestor. The closest known relatives to this are animals that live on coral reefs and deep marine systems, and a few other karst systems around the world. This is no slideshow on cave and karst would be complete. Cave and karst biology without showing a picture of Dr. John Holsinger. He's the one who got all this cave biology interest in Virginia started about 50 years ago, along with a couple of colleagues. But John, without John's efforts, this species wouldn't probably be known, and certainly we would not have a cave board or a cave and karst program. We lost John about 10 years ago, but we're all going to be kind of walking in his footsteps for as long as we're going in Virginia and West Virginia caves. Um, that particular cave that we showed pictures there, Madison Saltpeter Cave, where the species is known from, used to be a commercial cave, and you can see here some remnants of the old walkway. Anyway, sorry for hurrying through that last bit, but I know you guys probably have things to do and are tired of listening to me, so I'll take any questions.
Is there a book that has those photos in it?
So Katerina Kosich-Ficko, who works with
Many
me,
of the caves.
is now working on a photo book specifically designed to provide that for people. It's kind of unusual that, or surprising that no such book has been produced in Virginia that's accessible to the general public, and it's kind of a hole that's going to be filled hopefully when Katerina gets that book done.
Great.
Were many of the caves mined for saltpeter?
There were a couple dozen caves in Virginia that had a history of saltpeter mining. Some of them were very specific, were very extensively mined. Others, rumor has it that they were operated as mines as a way to do something other than carry a gun off to war. The a variety. Madison Saltpeter Cave, which the picture, last picture I showed, a few pictures was from, it was actually mined all the way back, starting in the War of 1812. So there was a long history of saltpeter mining in Virginia's caves. All that came to an end, of course, once the sort of seamounts in the South Pacific, once it became economic to move material from there to North America, and of course the Haber process was invented, fixing nitrogen from the atmosphere, which meant you didn't have to mine saltpeter anymore. But in the 19th century and before, saltpeter was critical for production of gunpowder.
There's a few questions in the chat. Did you need me to read them or you want to go over those?
Let's see. I'll see if I can pull it up. There we go. Oh, great question about white nose syndrome. So the question is, in the bat species affected by whiteness, has any resistance developed among the surviving bats? Well, Karen, who's here, probably could comment on this as well. What we see more in the caves and on the landscape is we see populations of affected species persisting and in some cases increasing. Uh, the genetic work that I know of about this has shown that the genetics of the little brown bat, for example, post white nose syndrome, uh, the expression of specific genes is either higher or lower than samples taken from little brown bats prior to white nose syndrome. So there looks like to be some type of broad selection process going on. Interestingly, the papers that I'm familiar with, at least, showed that those genes really have less to do with like a resistance or an immunity to the disease than they do with an ability to tolerate the presence of the pathogen. Um, I would hesitate to say that we're out of the woods in terms of white nose syndrome. Um, some things we see, like Karen and I were up together in a cave a few weeks ago up in Bath County, and almost all the bats that we saw that we had banded in the past were males. And so without female bats still around, we're not going to have recruitment and have more bats. So there's lots of puzzles as to and unanswered questions as to what recruitment or reproduction is going to be like moving forward. And it's probably going to vary species by species. So let's see. Another question. I'm a freshman in high school and I was wondering what the degrees are to do this cave work. Um, well, the degree probably matters a little bit, but what also matters is just getting involved in doing this kind of work. The people I hired, I work for a biology agency, but one of the number one criteria I had for hiring people to work in caves was the ability to travel through caves and to explore caves. So you could get a biology degree, you could get a wildlife science degree, you could get a geology degree like me, but you're going to have to be able to navigate caves in order to be able to uh, do this kind of work. So there's a combination of learning the skills to navigate caves safely and also the academic skills, and that's a hard combination. But it's one that if you go for it, you could get, I'm sure. And there's more jobs in cave and karst now than there have ever been, and that's still very, very few. Let's see. How many species of aquatic isopods live in Virginia? A few in a puddle next to a creek, and they are so cute to watch swim around. They sure are. And those animals are, I think we have groundwater isopods alone, just aquatic ones. We're probably sitting at around 68 to 70 if you count the ones that are currently being described. But if you go to the Virginia Museum of Natural History, you can actually download that Groundwater Isopods of Virginia book for free. And I encourage, if you're interested in isopods, go look it up because it's got all kinds of pictures and interesting texts and stories about the animals' names and things, technical drawings. Um, it's an interesting read. Nice photographs. Thanks for sharing those. That's neat. All right. Were you part of an event at the Cedars? Yes, I was. in 2018. I think we met at a Baptist church over there and went out. That's from Lucinda Jennings. I think I was there. I've been at several of them, and I think I was at that one. And if it was it was the Native Plant Society and the DCR together that day. Anyway, any other questions anybody has? All right. Well, thank you guys for the opportunity to speak to your group. And if you guys have interests in volunteering on the preserves to help maintain habitat, things like that, just get in touch with me, let me know, and I can help put you in touch with some of our stewards.